All right, Algebra 2 students, this is the answer key, or how to answer some of the questions here on the Unit 7 Formative 2 Review Worksheet, version 1. So I'm going to go question by question through this. So feel free to scroll ahead if you want to skip some of the ones that you already know. So number 1 is log base 5 of 1. So we want to simplify the expression, means we need to find out what is it equal to. So one method here would be to solve it for x. So to do that, you just write equals x on the side there, and then you can re-express this. So it's 5 to the exponent x equals 1. So what value for x would that be true? Well, it would have to be x equals 0. And all of these on this first section you could probably do in your head. However, later when it says solve the exponential equation, we'll go through on how to use logarithms to do that. All right. Number 2, ln of e, so it's natural log of e. So we know from in class that ln is the same thing as log with a base of e. So we're trying to find log base e of e, and that's equal to something. So I can find e to the x is equal to e. Well, there's really a 1 there, so that means x is equal to 1. And number 3, this time natural log of 1 over e. So I know natural log is the same thing as log base e. This is of 1 over e equals x. So I can circle e, right? E to the x is equal to 1 over e. So to get a fraction somehow, that exponent's going to need to be negative. So to get 1 over e, there's really an exponent of 1 on that e, so x would have to be a negative 1. And that's your answer for number 3. And moving on, number 4. Number 4, again, equals x. Circle the base, so it's 3 to the x equals 27. And that would be true when x is equal to 3, because 3 times itself 3 times is 27. And number 5, 4 to what exponent would give me 8? So I could re-express it to show you all the steps here. 4 to the exponent x equals 8. So you can keep guessing and checking. Again, later we'll show how to use logarithms to solve this, but this ends up being, 1 would be 4 to the first, which is 4. That's too small. 2 would be 4 squared, which is 16. That's too big. And you could guess and check, but eventually you're going to find that x equal to 1.5 is exactly the right answer. And so another way you could think of that is taking the square root of 4 gives you 2, and then cubing it would give you 8. So it's like 4 to the 1/2, and then you cube it. So take 3 times a half, you get 3.5, which is the same thing as 1.5. All right, number 6. Number 6 is, right, equals x. 3 raised to the exponent x equals 3 to the 4.6. So they both have the same base of 3, so that means the exponent should be the same if these two things are going to be equal. So x must be 4.6. And you're done. All right, number 7. Number 7, right, equals x, and 5 to the exponent x is equal to a fraction 1 over 25. To get fractions, x is going to have to be negative, and this is 5 squared here in the bottom, 25. So negative 2 would be the correct answer. Number 8. This one's an interesting one because you've got equals x like all the rest of them. So if I re-express this, this will be 4 to the exponent x is equal to a negative 16. But as we talked about in class, there's no way I could raise a positive number to an exponent and get a negative number. So that's why this answer is no solution. Okay, it would be undefined. Number 9, kind of like one we did earlier. So 6 to the exponent x equals 1. X would have to be 0. Anything to the power of 0 gives you 1. All right, let's move on to the next section. Number 10. Actually, psych. Number 9 again. My bad. Didn't catch that when I made this review sheet. So this time it says rewrite each exponential equation using logarithms. So if we circle the base like we have been doing, this time the base is 6. So we could write this as log base 6 of the other side, 5, is equal to the exponent on the 6, x. And that's all we have to do here is just re-express it using logarithms. So it goes pretty quick once you get the hang of that. So this one then would be log 5 of 1, log base 5 of 125 is 3. Oops, that's a 3, I promise. All right. Then moving on, number 11. This time we're going backwards. What if it starts as a logarithm and we want to write it using exponents? So again, all we're doing is rewriting. We don't need to solve anything. So circle the base. It's 3 to the exponent of the other side, 4, equals 81. Then you stop there. All you need to do is write it. So that number 12, this one's just slightly different. All you need to do is log base 4, so it's 4 to the exponent x minus 5 equals 7, and then you're done. All right, so we're on the back now. Number 13, directions say expand the expression. So we had certain properties we talked about in class that if things are multiplied together, we can split them up using logs. The property of logs, it says you can split them up using addition, so the product to addition rule. So I can split this up using log base 6 every time. So log base 6 of 5 plus log base 6 of x to the 5th plus log base 6 of y to the 8th. And then there's another property that says if you have exponents here, the exponent to coefficient rule says you can move that to the front. So as Mr. Zhang said in class, that falls off the log. So our final answer here is going to be, this first one stays the same. It's still log base 6 of 5. Sorry, this is really hard to type on or write on an iPad, so you'll have to listen to my voice and watch. So plus 5 log 6 of x plus 8 log 6 of y. And similarly, for the next one, this one uses a different rule. This one we have to use the rule for division. And if it's division, we separate the logs with a minus. So the final answer here is going to be log, actually the next step, not the final answer, is going to be log base 3 of x to the 4th minus log base 3 of y to the 9th. And then your final answer happens after you move these exponents to the front. They fall off the log. So final answer is 4 log base 3 of x minus 9 log base 3, that's a 3, of y. And that's the answer. Okay. Number 15, log base 8 of 4 plus 3 log base 8 of y. Since they're the same base, we can combine these. We can condense them into one logarithm expression. So since it's addition in between, we can combine them using multiplication. But first, I need to take care of any coefficients, which there is one, on the second term and move that to the exponent. So it would be log base 8 of 4. That one remains unchanged. The second one becomes log base 8 of y to the 3rd. And then we can combine them using the sum to product rule. So log base 8 of 4y cubed. And that's your answer. So using the same thing, same properties here, there's an addition and a division, addition and a subtraction one. So it's going to be multiplying between the first two, but dividing on the last term. So take care of coefficients first. 3 goes up, 1/2 goes up. So log base 7 of x to the third plus log base 7 of y to the 1/2 minus log base 7 of 5. And now multiply the first two. So log base 7 of x to the third y to the 1/2. What's next? Divided by, since it's minus, a 5. And that's your final answer. And now some graphs. So it says graph each equation. So we talked in class the best way to do this is, you're going to need a calculator too for this one. So if you've got something written like that, so you're going to circle the base and re-express this as 4 to the y equals x. And since it's already solved for x, that's what we're going to use. And we always use the same numbers, -1, 0, and 1. And so now you're going to plug those values in for y to find out what x would be. And I'm not even going to try to graph this on the iPad. It's going to be too difficult, but I'll show you what the x values are. So -1 in for y is going to be 4 to the -1, which is 0.25 exactly. And then the other one's 4 to the 0 becomes 1, and 4 to the first becomes 4. So use those, put those in this table, and then graph those on the graph. And then I'm not going to try and be precise because it's really difficult to do that on the iPad. All right, so you're on your own there. But I'll show you the last one here. So y equals natural log of x minus 1. I'm going to zoom in a little bit because I'm going to need some room. So natural log is the same thing as log base e. So I'm going to rewrite this as y equals log base e of x minus 1. Then re-express this. Circle the e. It's e to the y equals x minus 1. But that equation is not solved for x yet. So I'm going to add 1 to both sides. And so now my final equation here that I'll use is going to be e to the y plus 1 equals x. So final equation, e to the y plus 1 equals x. And that's what I'm going to use to plug in same values, -1, 0, and 1. So just real quick, I can show you what that would be. Let me zoom in a little, zoom out so we can see everything. Okay, so e to the -1 is 1 over e, or as a decimal in your calculator. I got a calculator to the side of my iPad here, so if I do 1 divided by e to the first, I get 0.4 approximately, 0.4, and then e to the 0 as, oh, but then you need to add 1, so this is really 1.4. E to the 0 plus 1 is really like 1 plus 1, which is 2. And the last one is e to the first plus 1, which ends up being 3.7 approximately. So again, you graph it. I'm not going to try it on the iPad. All right, last page here. Sorry this video is extremely long, but just want to make sure you had an explanation for everything since I'm going to be gone today. So we need to solve using logs now. Now you can use natural log or log. I'm going to use log mainly for all of these. So if I do the log of both sides, just write log 64 of 4x, or to the 4x is equal to log of 8. And then rule for exponents here, I can move 4x to the front, so then it becomes 4x log of 64. equals log of 8. And then divide both sides. Divide both sides here by 4 and log 64 to get x alone. Because 4's go away, log 64's go away. Whatever you do to one side, you got to do the other. So 4 log 64. Make sure when you plug that in the calculator, you put parentheses around the bottom. So final answer is x equals, using the calculator I have here to the side of my iPad, I've got log of 8 divided by parenthesis 4 log of 64. And I get a nice decimal, I don't even have to round it, 0.125 is the answer. So the next one, similar process here. So log of 3 to the 2x equals log of 144. Rule of logs, bring the 2x down. So 2x log of 3 equals log of 144. And now divide by 2 log 3 on both sides. Make sure that goes in parentheses. You would be left with x equals, using the calculator, log 144 divided by, in parentheses, 2 log 3. I get a decimal I'm going to have to round, 2.26185, so the 8 rounds up to a 9. There it is. Okay, next one, 21. This one's already got log in it. So, and it doesn't give me a base for that log, but I know when it doesn't have a base, we know it's assumed to be 10. So I can simplify this by re-expressing 10 to the exponent of 3 equals 2x plus 5. So 10 cubed is 10 times 10 times 10. So I know that's 100 times 10, which is 1,000. Equals 2x plus 5. And you can use a calculator for that if you don't know how to multiply by tens, although you should. It's Algebra 2. So then subtract 5 and get 995 equals 2x divided by 2. And if you can't do that in your head, geez, can I do that in my head? 497.5. So 497.5 equals x. Answer. 22. This one's already got the base there, so I don't need to make it up. Even though I didn't make it up, we just knew it. So 8 to the exponent of 1/3 equals 4x minus 6. So 8 to the 1/3 equals 4x minus 6. Now, if you take some number to an exponent in the fraction, you know that's the same thing as taking the root of that. So the 1/3 exponent is the same thing as a cube root of 8, which is 2, or if you don't remember that, you could let the calculator do that. 8 to the 1/3, it will tell you 2. So then the rest of this is easy Algebra 1 stuff. So add 6 and get 8 equals 4x. Divide by 4, x equals 2. 23. Natural log becomes log base e of 3x equals 5. Re-express it, circle the e. E to the exponent of 5 equals 3x. Well, e to the 5 is a number, so to get x alone, all I need to do is divide by 3. And let your calculator do the rest. So in my calculator, I have e to the 5, or the 5th, and divide that by 3. And I get x is equal to approximately 49.471, and then the next number is a 0, but the one after that's a 5, so it's going to round up to a 1. So 49.4711. And then to finish this out, the last question, e to the x plus 5 equals 37. All right, so let's take the log of both sides, or you can take the natural log. Since it's e, it might make it a little easier. But if you don't do it that way, I'll do it the harder way. I'll do log of both sides. So if I take the log of both sides here, log of e to the x plus 5 equals log of 37. Rules of logs, x plus 5 comes to the front, so I have x plus 5 times log of e equals log of 37. And then I can divide both sides to get x plus 5 by itself. Divide by log of e on both sides. And then these will go away, so I'm left with x plus 5 equals, use my calculator for this, I've got log of 37 divided by log of e. And that gives me 3.6109. And then finally, subtract 5. So 3.6109 minus 5 is, you get a x equals negative 1.3891. And there's your final answer. All right, that's it. I hope you have a good weekend, and I will see you on Monday.